What if I told you that nearly 85% of the matter in the universe is completely invisible to us? That it's not made of stars, planets, or even atoms? Instead, it's something more mysterious, more elusive. Meet dark matter, the cosmos's greatest riddle. Hello, curious minds. Today on Scientific Facts, we're unraveling the enigma that astrophysicists have been scratching their heads over for decades. Dark matter. What is it? How do we know it exists? And why is it so important for understanding everything, yes, everything, in our universe? Buckle up, because this journey will change the way you look at reality itself. First, let's go back to the 1930s. Swiss astronomer Fritz Zwicky noticed that galaxies in distant clusters were moving at such breakneck speeds that they should have torn themselves apart. And yet, they held together. The visible matter, the stars, the gas, wasn't enough to account for this cosmic glue. Zwicky called this missing ingredient dark matter. Fast forward to the 1970s. Enter Vera Rubin, an observational astronomer whose research on the rotation of galaxies provided even more compelling evidence. Rubin observed that stars on the outer edges of galaxies weren't rotating slower, as gravity laws would predict based solely on visible matter. Instead, they were zooming around at almost the same speed as stars near the galactic center. There was only one explanation. An invisible halo of matter surrounds each galaxy, an unseen mass pulling on those speeding stars. This was dark matter flexing its gravitational muscles. So, what do we know about dark matter? Weirdly enough, we understand it better by what it isn't rather than what it is. It doesn't emit, absorb, or reflect light, which makes it invisible to telescopes. It doesn't interact with normal matter in conventional ways. No colliding, no sticking, no reactions. But it does have mass, and mass means gravity. Gravity, of course, shapes the universe. So, could dark matter be made of some exotic particle? Scientists theorize it might consist of WIMPs, weakly interacting massive particles, or MACHOs, massive astrophysical compact halo objects. However, despite decades of searching, no one has directly detected dark matter yet. It's as though the universe is playing a cosmic magic trick, hiding its greatest clue in plain sight. Still skeptical that dark matter exists? Here's some food for thought. First, examine gravitational lensing. Imagine a glass lens bending light. Similarly, massive objects in space, like galaxy clusters, warp space-time itself, bending light from background galaxies. Often, the observed bending is too extreme to be explained by visible matter alone. Dark matter fills in the equation. Second, cosmic microwave background radiation, the universe's oldest light, reveals subtle patterns of heat and cold that match predictions if, and only if, dark matter were present during the early days of the universe. It's like finding fingerprints at the scene of a cosmic crime. Now you might wonder why dark matter is such a big deal. Isn't it enough to study stars, black holes, and quasars? Not quite. You see, dark matter acts like the scaffolding of the universe. It provided the gravitational pull that allowed galaxies to form from primordial clouds of gas. Without it, the stars and galaxies we see today simply wouldn't exist. The universe as we know it wouldn't exist. But dark matter's not just an ancient relic. Even now, it influences the way galaxies collide and form clusters. And here's a chilling thought. Without dark matter, our Milky Way might never have formed, leaving our solar system and us lost to history. So, where do we go from here? Scientists worldwide are hot on the trail. Deep underground, detectors sit inside shielded facilities, waiting for the faintest interactions between dark matter particles and ordinary matter. High above us, telescopes scan the skies for indirect evidence, like bursts of gamma rays that might accompany dark matter annihilation events. Even particle accelerators like CERN's Large Hadron Collider are in the race. By smashing protons together at incredible energies, physicists hope to recreate the extreme conditions of the early universe, maybe, just maybe, producing a dark matter particle in the process. But what if we're looking in the wrong place? Some theorists suggest we may need to rethink the very nature of physics to understand dark matter. What if it's not individual particles at all, but rather a property of space-time itself, or a manifestation of higher dimensional realities? We're not just searching for a needle in a haystack. We're questioning if we even understand what a needle is. And there you have it, the dark matter dilemma. A puzzle that's not just reshaping how we see the cosmos, it's reshaping the very questions we ask about existence. The stakes couldn't be higher, because solving this mystery won't just unlock the secrets of the universe. It may uncover something more profound, our ultimate place in it. So, the next time you look up at the night sky, remember, most of the universe is not what it seems. Beneath the twinkling stars and swirling galaxies lies an unseen realm, just waiting to be understood. Who knows what stories it will tell? Thanks for watching Scientific Facts. If you enjoyed today's episode, don't forget to like, comment, and subscribe. And as always, keep looking up.